All right, today we are talking about extrema and end behavior. So extrema is going to relate to the word extreme. So these are extreme values. They're the maximum and minimum values of a function. So when you talked about quadratics, you may have already found some max and min values. Today we're going to do more of that. And then sometimes there are certain forms that you're going to have to put them in. So we want to make sure like we're reading the directions so that we have an accurate solution. So if it's a maximum, it's the highest point on the graph of a function. So there's only one of them. So this would be a maximum. Now there are what are called relative maximums, and that's going to be where no other nearby points have a greater y-coordinate. So you might have a graph like this, okay, where you have a curve and then it's continuing. And then this here would be a relative maximum. So I just put RM. So it's the maximum value in this area. It's not the highest point because look, this is going to infinity. So there's going to be points higher than this, but if we just zone in on this area, it is the highest point in that area. And then the minimum has a similar explanation. So it's the lowest point, okay, if it's a minimum, but if it's a relative minimum or what's called a local minimum, okay, then it's the lowest point in this area, not necessarily the lowest point on the graph. Because if you have this arrow going down, you're going to have lower points here. Now the plural form of maximum is maxima. That's why if you have more than one, you'll hear maxima or minima. And in some cases you have one, in some cases you have more than one. Okay, so for our first examples, it says identify and estimate the x and the y values of the extrema. So if you see extrema, that means you have to find the maxes and the mins. And if it says that you're going to find the x and the y values, then you are going to write them as a coordinate point. They don't always ask you to write it as a coordinate point, so that's why I'm drawing your attention to that. And if you need to, you will round to the nearest tenth. We're going to do this more frequently when we're using a calculator, but because we're doing estimations with the graph, we aren't going to have to do that much today. All right, so we're finding the relative max and the relative min. So the relative max, you're going to have one right here. And then because it's an xy value, we are going to write that as a point. Okay, so if it doesn't have any labels, it'll be 1 unit. So negative 1, 2 is your relative max. Okay, and then your relative min is going to be right here. So I'm over 1, down 2. So 1, negative 2. And in this case, they happen to be opposites. That does happen sometimes, especially if you have the symmetry. All right, so can you guys give number 2 a try on your paper? If they have the opposites, then yeah, you should be able to rotate it one side onto the other. Yeah, because it'll be a 180-degree rotation. Yeah. All right, let's see if we found our relative max, our relative min. So this time the maximum is on the right side, and it will be at 1, 4. Your relative min is on the left, so that will be at -1, -4. Okay, so this was an example where you just had one of each. For the ones below, we are going to have more than one. So for your relative minima, you're going to have 2 of them. Okay, now notice with these, your y scale is by what? Not by ones anymore. What is it going by on the y? Yeah. Okay, so this is -20, but it doesn't look like it's exactly at -20. It looks like it's a little bit above it. So this is going to be at -2, -19, and at 2, -19. Okay, and in this case you have opposites here, but those are the same. Okay, and it's okay to have 2 relative min and only 1 relative max, which is what we have. And in this case, your relative max is also going to be a y-intercept. So again, to me, that looks like it's a little bit above the line. So if we're going by 4s, this would be 0, -3. Okay, and then I'll give you a few moments to identify the relative min and relative max for 4. And once you've done that, go ahead and read through number 5. All right, so let's see what we got for our relative min. Okay, so we got 0, 5. And then our relative maxima, we have 2 of those. Okay, so they occur at -1, 6 and 1, 6. No. Nope. So you can put those in any order. So did you do the 1, 6 first? Yeah, that's fine. All right, now we're going to apply this to a real world situation. So I talked to you a little bit earlier this week about in honors, it's more than just finding things. We want to find them and then interpret them in context. So for 5, Carlos's score on a video game after X minutes can be modeled by the graph. You're going to estimate the X coordinates at which the relative maxima and relative minima occur, and then describe the meaning in context of the situation. So the first thing we're going to do is estimate the X coordinates. So you don't have to estimate the Y. So we're going to write this in a special way. Whenever they just want you to find the X coordinates, we say like the relative maxima occur at, and then we'll label what the X values are. Okay, so we write that down with me. And you'll have your values for X. This is commonly how you'll see it. And we are going to find that in a second. And then after we find those, we are going to describe the meaning. Okay, so for this, it says it's a score on a video game after X amount of minutes. So the graph here, we are going to label that. So if it's X minutes, we know that the minutes are at the bottom of the graph. And then if they don't give you a scale, it's by ones. So it's 1, 2, 3, 4, 5, 6. Now it doesn't come out and say exactly like, oh, why is this? But based on that first sentence, what is the Y value? It's his score. Okay, so it's the score of the game. Okay, and again, it doesn't give us what those values are, so they're just going to go by ones. And sometimes I just label every other one so they're not all close together. Okay, so now we're going to find the relative maxima. Now, the relative maxima and the relative minima are not going to be at the start or at the end of the graph. It's going to be in between the starting and the ending value. So do you guys think that you could label on the chart where the maxes are and where the mins are? Yeah? Okay, so let's do that then. Okay, so can't be the start, can't be the end. So we have a max here. We have a max here. Then we have a min here. Okay, so because it's just asking for the x coordinate, then your max value is going to occur at x equals 2 and at x equals 5. Okay, and then we only have one of the minimums, so we can just say the relative, you can say minimum because there's only one. I'm even okay if you say min. Okay, so the relative minimum occurs at x equals, and then will you identify that on the chart for me? Okay, and then Jaden, will you tell me what you got for your x value where the min is? Great. Okay. Oh, you can just say at, the occur at, yeah. Okay, and then we also need to describe the meaning. So what does this mean in the situation? Okay, so remember, this is about Carlos's score. So what's happening at these max places? Yeah, his score is higher, right? And then at the min, his score is lower. So we're just going to say that Carlos's scores peak at the 2-minute and 5-minute mark. So write this down with me. And we could say they dip at, and then the lower one was at 3, and they dip at 3 minutes. You can also say, instead of dip, you can say they reach a low point. You can say Carlos's scores reach a high point at 2 minutes and 5 minutes. Who's that? Maybe his little sister was getting on his nerves during this point. He wasn't trying so hard. All right, any questions for me on that one? All right. Then we're going to learn about end behavior. So this is likely something that's new for you. And I'm going to try to explain it in a very simple way for you. The end behavior is going to tell you what happens in a graph. So it describes the behavior of a graph as the x values get very, very large or very, very small. Okay, so as Okay, so it's going to be as x approaches positive or negative infinity, which again means as x is getting very, very large or very, very small. So to help you visualize this, we're going to draw just a coordinate grid here of y and x. Okay, so it says as x approaches positive or negative infinity. There's always going to be a left side of the graph and a right side of the graph. Okay, there are always the two ends to each side. Okay, so the two ends are going to represent the left side and the right side. So on your x value, we know that this is positive infinity and this is negative infinity. When you use those symbols in relation to x, this means the right side of the graph, and this means the left side of the graph. Okay, so with respect to the x-axis, if you use positive infinity, it means what's happening on the right. If you use negative infinity, it's what's happening on the left. Okay, now on the y-axis, those two symbols, we use them, they just represent two different things now. We're still going to use negative infinity and positive infinity, but they tell you at the end of the graph if it's rising or falling. Okay, so we're still using these symbols, negative infinity and positive infinity. But now for the y, they represent, if your graph is going up, that means positive infinity. If your graph is going down, it's going to be negative infinity. And just do the best you can with this symbol. It takes practice. If you need to write two zeros or two ovals next to each other, you can do that. And so what we do is we create a mathematical sentence. So we use symbols to describe this end behavior. So what I did is I wrote out for you the format we're always going to use. So we're going to box this in here. You are always going to have this as part of your answer. Okay, what this is saying is as x goes to negative infinity, y goes, and then I put a blank because that's going to change. So depending on what your graph is, we're going to fill in this blank. And then this is saying as x goes to positive infinity, or as x is approaching positive infinity, y goes to blank. So again, this is going to change. Okay, the reason why these two don't change is because your graph always has a left and a right. You're always going to have a left and a right, but they don't always have to go up and they don't always have to go down. So those are going to change just depending on what your graph looks like. Okay, so when you're filling in these blank spaces, you're going to use positive infinity if the end is going up. So if it's rising or going up, you're going to put a positive infinity in this blank space here. And you're going to use a negative infinity if the end is going down. So we're going to do a couple of these together because I know this format is new. So like I said, you're always going to use this. Have your English teachers ever given you like sentence stems? They'll start a sentence for you and you'll finish it. That's basically what this is. I'm starting the stem for you and you're finishing it. Do you guys want to go play tennis?
Let's play tennis.
You wish you had that. Okay, so every single time you are going to have as x goes to negative infinity, y goes to, and then we're going to fill that in. So we're going to do 6 and 7 together. So we're going to set this up for both of them. As x goes to negative infinity, y goes to something. As x approaches positive infinity, Y is doing something here. Okay, so again, I just want to be clear that what this is telling you is on the left side of your graph, you're going to say what Y is doing. On the right side of your graph, you're going to tell me what Y is doing. Okay, so let's look at our graph. We have two ends. Is this side the left side or the right side? Left. Okay, this side is the right. So all you have to do is tell me where this is going. So if this is going up, you are going to say that Y is going to positive infinity. And on this side, it is going down. So you are going to say it's going to negative infinity. Okay, and this is the only thing that you have to write. Okay, but what this is telling you is, oh, on the left side, the end is going up. On the right side, the end is going down. Okay, that's what that means. So you won't have to do this for lines that are not continuous. Because yes, you would not be able to do, you wouldn't be able to do it if it was a mixture. And if it was discrete, you wouldn't have any arrows. Yeah. A lot of times we do this with particular functions of polynomials, and we'll actually study that down the road as well. Okay, so for 7, we're going to do something similar. We know that on this side, it's going up. So on the left side, it's going up. On the right side, it's going up. So if it's going up on both sides, what am I going to fill in here for Y? So this is positive infinity, and this is positive infinity. Okay, so this is saying on the left, it's going up. On the right side, it's going up. All right, you guys think you got the last two? Okay, so you guys do those if you haven't already. If you have, you guys can check in with an elbow partner. Make sure you guys have the same thing. Okay, and then once you've done 8 and 9, you can read through 10. We are going to do that together. Okay, so for number 8, both sides are pointing down, right? So that means both of these have to go where? Negative infinity. So if both sides are going down, okay, on the left and the right, okay, you're going to have negative infinity for both of those. Okay, and then number 9, we have opposites. So you should have one going to positive infinity and one going to negative infinity. So on the left side, it's going down. On the right side, it's going up. Okay, how are we feeling about this? You good? All right, so now we are going to apply this concept to a real world situation, which means we're going to have some restrictions because because the real world has restrictions. We're not having things go to infinity here. So this is about throwing, and the graph shows the height y of a ball that is thrown from a balcony after x seconds. So it's thrown from a balcony, that's why it's starting up here at 50. Okay, and then we have to describe and interpret the end behavior in context of the situation. Okay, so we're going to describe and interpret. So describe, we're going to be using something similar to what we did up here. It is a little bit different. And then we are going to explain what that means in the context. So one thing I like to make sure I understand is what my variables represent. So the height y of a ball, which in this case is measured in what, according to our graph? Yep, in feet. And then the time, which is measured in seconds. Okay, so when we're thinking about time, and this graph shows it, our time can't be what? Well, for this particular situation, yep, it shows that. What else? Yeah, your time, see how the time starts at 0 and it's only going up? So before we were saying what happens as x goes to negative infinity, we're not going to do that now. So we're just going to make a little note. This is so that you understand why we're getting the answer that we're getting, so you can apply it to different situations. Okay, so time can't be negative. So that means your function is not defined. Okay, time can't be negative in this case, so the function is not defined for all the values of x where it's less than 0. If the time is less than 0, it's not going to be defined here. So what that means, it's asking you to describe the end behavior. You're not going to have any end behavior as x approaches what value? Right. So you don't have to do the end behavior for x goes to negative infinity. Okay, so in your practice problems, you'll want to keep that in mind, okay? All right, so that means we do have to describe what happens as x approaches positive infinity. So our end behavior, I'm just going to put EB, okay? Our end behavior is as x approaches infinity, and this is a little bit tricky. So before, if we had an arrow going down, we would just say that it is approaching negative infinity because it goes down forever. But we're throwing a ball. I know some of you are strong, but we're not going to be throwing a ball off a balcony that's going to go up and then penetrate through the ground, right? Maybe some of you will find that a challenge. No, what's going to happen? It's going to approach what value? It's going to approach 0. So as x gets larger, y is getting closer and closer to 0. Okay, so that's the describe. Now we're going to do the interpret part. Okay, so that's like, what does this mean in context of the situation? So we know that t is the time. So we can say as the time passes, the height of the ball approaches, and you guys already told me that it approaches 0. We're just going to put units with it and describe why. So the height of the ball approaches 0 feet because what's actually happening? Where's it going? What's happening? What's it doing? Yeah, it's just falling to the ground. Nope, not going to happen. If any of you can make it go negative feet, you let me know. Yeah, it has to be really heavy. Yeah, I don't know. Okay, so I'm going to give you some time to work on your homework. Your homework is actually very short and sweet today. Okay, so this is on page 27 of 1.3. You only have to do 1 through 5, the odds. So 1, 3, and 5, 7 through 10, and 32. Okay, and that is due tomorrow in Google Classroom.